Hey everyone, my name is Vedelin, and in this video we're going to take the latest open model from Google Deepmind called Gemma 3 for a test. Gemma 3, as the name suggests, is the third iteration of the Gemma family of models, and for a first time it provides vision capabilities that are essentially baked in within the model. It comes in 4 different sizes: 1 billion, 4 billion, 12 and 27 billion parameter models. The vision capabilities are available for models of 4 billion parameters and up. Gemma 3 is multilingual supporting model, and in their blog post they say go global in 140 languages, and for the instruction tuning part they support over 35 languages, and within the pre-training dataset they had over 140 languages. Offers a 128k context token window. From what I've read, actually the model supports initially 32k context window, and then via rope support that was extended to 128k token context window. Another important thing here is that, at least in the blog post, they say that it supports function calling and structured output, at least as of now. Within the Ollama setup that I'm going to show you in a bit, the model states that it doesn't support function or tool use. And another important thing here is that the Gemma 3 team is introducing official quantized versions. That is, the model that we're going to load within our local Ollama instance will actually be official or published by the Google Deepmind team itself. One important fact about the Gemma 3 family of models is that the Google Deepmind is actually releasing a set of both pre-trained and instruction-tuned models. So if you're going to do some fine-tuning, you might choose to start with the base models or the pre-trained models, and then further tune your fine-tuning with instructions based on your needs. Another important thing is that they have the instruction format or prompt format within their technical report. And here you see that the model is actually expecting a beginning of sequence or BOS token at the start. Then they have a special token called start of turn, then the row of the message that is happening, in this case the user, who are you, and then end of turn for this message, start of turn with a model, the response, etc. So this is how you should build your conversation formats. Another important thing, at least from what I'm seeing right here, is that system messages are not really supported within the Gemma model. And what I've seen, at least in the Ollama implementation, is that the system prompt is actually prepended with the user prompt that you're going to give. So keep that in mind, that actually system prompting within Gemma 3 is not supported. For our testing, I'm going to be using the model from Ollama, and this will be the 12 billion parameter model. I'm going to run it on an M3 Pro base machine. The only library that we're going to be using for our testing is going to be the latest version of the Ollama Python client. And here you see the parameters that I'm going to be using for this test. These parameters were recommended by the Gemma 3 team as pretty much optimal, or what they were using to do the testing of the model. And from what I've tried, these parameters do seem to help a lot with the performance of the model. Of course, that would be highly dependent on the size of the model and the task that you're going to try out. But these are the parameters that I'm going to be using, as well as the 12 billion parameter model, as I've already told you. So calling of the model, it will be ollama.chat. I'm going to specify the parameters here. Hopefully all of those parameters are actually passed to the model thanks to the Ollama instance, but I'm not really sure about that. And I will also be able to pass in a parameter for the response format, either a text or a JSON, if that is required by the prompt. So the first thing that I like to try is to give some sort of creative task to the model to just have a look at what format I'm going to get as an output, the length of the format, and whether or not the output makes sense. So the first thing here is to ask for a hip hop lyrics for a song that is having 90s aesthetics from hip hop era combined with futuristic AI technological future. And you see here that the output of this prompt took roughly 2 minutes and a half, just probably to load the model into the memory and then starting producing that. Also, the response is quite long since this is a song, as you can imagine. So the first thing that I noticed here is that the model prefers to use Markdown as formatted output, which is great. And here is the response. You see that it is very nicely formatted, MC logic, word, check the mic, etc. Yeah, it seems like the format is great. The lyrics are also very good. Maybe not as good as Sonnet 3.7, but still it looks quite good. Most of the LLMs nowadays have good coding capabilities, and even though some models are specifically tuned or trained for that, we would expect a model such as Gemma to be very good at coding. And unfortunately, most of the LLMs, or at least the open LLMs that I've tried within this task that I'm going to show you in a second, have failed pretty badly. Even some of the large behind API models are, again, not able to do this task, at least from what I've seen. And the task is pretty simple: generate a dataset of wealthiest people of each continent for each person. The data should contain name, gender, wealth, and continent. The dataset must contain at least 1000 examples. Create a pandas data frame that gets the top 5 wealthiest people for each continent. Sort the data first by continent, then by poorest to richest. And this took roughly 40 seconds to generate. And I'm going to show you the actual source code. Very nicely formatted. I would say here the genders are only 2. Some of the models are adding more genders in here, which is crazy. And then we have the names of the people, simplified name generation with person. Then we have some random choices of the gender, and then the random initialization between 100 million and 300 million. So all this seems very reasonable, as well as the data frame creation at the end. Very clean code, I would say. And then here for the get top 5 wealthiest by continent, you note that the model has actually chosen to generate or create 2 different functions. This is very similar to other solutions that I got from similar models. And it has some error checking if the data frame is empty, etc. And then this is the actual code, which, as you can see, is pretty simple. And most of the other models haven't been able to create this code for me. Of course, that would require some pandas knowledge. Here, the model is wanting to sort first by continent and then by wealth, just as I've asked in the description. And then once this is sorted, it is grouping by the continent and then getting the top 5 results from there. And this is the response. Here is the call for the functions. And here you see that actually we got the correct sorting on the continent first, and then the wealth from poorest to richest. No warnings, no nothing. The code works as expected. I'm really glad that this model was able to produce that. I would say that this is the best model thus far that I got within this task, at least, and that is running within, let's say, 7 to 15 billion parameter models. I believe that even the Quen bigger models were not able to handle this task, so I'm pretty happy with that. Then for some data labeling, at least the author of Gemma 3 are saying that the model is very optimized for such tasks as text understanding, instruction following, summarization of text, etc. And I have 5 different tweets that are very possibly within the training set of this model, but that wouldn't matter that much. And why I would like for the model to get multiple classification on target audience, tone or sentiment, complexity level, main themes or topics. And this took roughly 22 seconds, as essentially we got 4.5 seconds for each of the tweets, since we got the 5 tweets. And this is the response that I got. The response this time was asked to be in a JSON format, and the model has perfectly created the JSON responses. And you see here that we have audience, tone, complexity, and topics. I would say that this is pretty much perfect for, at least for the topic. And note that many of the other models, even though I have instructed them that I want a single topic to be classified for each text, there were instances where multiple topics were produced by the model in a form of list or something else. And here you see that the model is actually following my instructions pretty well. So again, a great job on the Gemma team. Okay, so here is a sample response that you'll see. The tone, etc. Everything, at least until now, seems very pleasant. And here I want the model to create me a summary of a earnings report from Meta. Now that this report is roughly an year old, I'm pretty sure that it is within the data set, but even still, I've asked the model to create me a summary within 3 to 4 sentences. And here you note that the actual model is still preferring to output this as a markdown format, which is great, at least for this task. So I didn't ask for a markdown, but the model was good enough to understand that this would be a good format for formatting it. The first thing that I noticed is that the company experienced revenue growth through the specific percentage isn't explicitly stated. I would say that this is a pretty big miss on the model's part. The summary with that I am pretty on board with strong financial performance and its focus on returning capital to shareholders through stock buybacks. So this was a key point within the earnings report, and the model catch that one very nicely. The report is also like 3 or 4 pages in markdown format, so this actually did a good job on that. Then I wanted to create a LinkedIn post of this actual report, and this is what I got. Here I was a bit disappointed since the model started with options, which again can be a good thing, but I didn't see a report that I really liked. I mean, those reports were like very badly formatted, no new lines, etc. Even if I asked the model to format this correctly. Another important thing here is that the model is trying to engage in a conversation. This is very similar to what we got within the Grok model and the Quote 3.7 model, probably in GPT 4.5. What is the key message you want to convey? What is your target audience on LinkedIn? These are questions that the model is asking you in order to generate probably better responses. So it would be interesting to deep dive into chatting with this model itself. And within my previous video on the Mindoro project, that is the wellness coach that is running completely locally, you see that the model is performing very well on instruction following and understanding what you want from it. So again, not the best LinkedIn reports here. Next, I'm going to continue with extracting information from this receipt right here. And since the Gemma family works quite well with both text and images, I'm going to try the both approaches. So first, I'm going to be using a markdown representation of this one, and I'm specifying something that I want to get a response, something like this. But within the markdown, there is an error in parsing the document with the service that I've used. These two wines, meat and produce, are actually inwined with the red and gold potato and BLNOS sirloin steak, respectively. So those are on a single line. And from the output or the prediction, you see that those are actually added to the wine items, which is incorrect, of course, but the model doesn't have the image itself. So if I try to pass the image to the model, you see that I'm using the Ollama chat with all of the parameters that we've specified, but this time around I'm adding an image path, and the first prompt that I'm starting with, what is this, to describe what is on the image and cite every number that you deem important. And here is the response. Again, this response is formatted in Markdown, which I very much like. Here is a breakdown of the information on the received image with important numbers cited. General information store, Piggly Wiggly, down home, down the street, etc. Time, date. And note that this is understanding just the image. I haven't passed the Markdown text with that. We have a financial summary, subtotal, tax total, debit card amount, etc. This is pretty impressive for 12 billion parameter model that was primarily trained on textual data. Of course, I still think about the vision capabilities of these models are a later add-on, even though this is not the case, especially when training those large models. The textual data is vastly more as important during the training compared to the visual capabilities of those models. So next, I'm essentially redoing the Markdown example, but this time I'm just passing in the image and not the text of the Markdown that is extracted from the image with the OCR2 that we were using. And here is the response, again, just with the image. Piggly Wiggly store name, date, time, total amount, tax amount, debit card. And here you see that those line items are actually very much correct compared to what we got within the Markdown. So I'm very impressed with this model. And if I was using probably the 27 billion parameter model, those results might be even better compared to what we had here. So next, for the RAC implementation of this model, I'm going to be reusing again the meta earnings report in a Markdown format, and I'm going to ask some questions. So first, within that report, it contains the sentence, "It's been good start of the year," Mark Zuckerberg said, Meta founder and CEO. The new version of Meta AI with Ollama 3 is another step towards building the world's leading AI. And I'm asking essentially this question: what is the founder of the company most proud of? So it must understand that the company we're talking about is Mark Zuckerberg, and he is the CEO of Meta. And here is the response, which is a bit disappointing. The provided text does not mention the founder of the company or what they're proud of. It only contains financial statements and cash flow information. Again, this is incorrect. Then again, another question that I'm asking: absent any changes to our tax landscape, we expect our full year 2024 tax rate to be in the mid-teens. The effective tax rate for 2024 is approximately 14.3. This is calculated by dividing the income tax expense and the net income, etc., etc. Yeah, this might be correct, but I just wanted here, at least this is a bit subjective, of course, since those basically those numbers are pretty similar. I just wanted the model to state that this was mentioned within the text, and then it would have been great to see the calculation as well. So this is only like half a fail, at least for me. Next, I want to extract those numbers essentially from the report, since this is available as plain numbers within the earnings report. And you see here that the numbers are actually correctly extracted. So this appears to be working great. And most of the models that I've tried are performing very well, at least with this table. And then another one that is a bit more complex, since more numbers need to be fetched from different places within the text. Here you see the numbers again available within the text. None of this is actually correct, and I have double checked. It is doing some calculations, etc., and not using the data that is available within the Markdown. So this is it for this video. We've seen the performance of the Gemma 3 model with the 12 billion quantized version of it. And I would say that for a 12 billion parameter model, it performed quite well. I haven't seen any hallucinations apart from the calculations that it did. And on top of that, the model was performing quite well on tasks that even proprietary or large language models weren't able to perform that well. I also like the markdown output formatting that the model is striving for. And if you're actually interested in a model that is an uncensored version of the Gemma 3 models, here Maxime Labon is also providing the versions for 12 billion parameter model, 27 billion parameter model, and 4 billion parameter models. And here there is also a link to how he got this technique to work. And probably you can try to do or test this model on your own for yourself. Thank you for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description of this video. And I'll see you in the next one. Bye.